In this video, we're going to go over another 1D kinematics problem. So in this problem, we have a particle that starts from rest at a point 10 meters from the origin at time equals 0. So I'm going to have one here. So here, let's call this our origin. And right now, we have a particle that's sitting about plus 10 meters. And this is at time equals 0. So then it begins to accelerate at -2 meters per second squared. So what that tells me is that this particle at 10 meters is going to start moving in this direction because it is accelerating at -2 meters per second squared. At t equals 4 seconds, the particle has reached a certain speed. It stops accelerating and continues traveling with the same speed at t equals 7 seconds. What is its position at t equals 7 seconds? Draw a velocity and acceleration graph from t equals 0 to t equals 7 seconds. So this is like one part of the problem, finding position and then drawing the graphs. So here, pause the video and try this problem. Okay, so this problem I'm going to kind of break up in two steps. So the first step is to find the velocity at t equals 4 seconds. Find the velocity at t equals 4 seconds and the displacement in that time. So right now we're just going to focus on the part where the particle is accelerating. So at time equals 0, it's at rest. So we know that our initial velocity is 0 meters per second. And we're trying to find the final velocity at t equals 4 seconds. So our time is 4 seconds. And we know that the particle is accelerating at -2 meters per second squared. So here, to find my v final, I can use v final equals v initial plus acceleration times time. This is one of our kinematics equations. So here we know that the initial velocity is 0. We know our acceleration is -2 and time is 4. So the speed is -8 meters per second. So now my particle at t equals 4 seconds has a speed of 8 meters per second, and it is in this direction. So we've got this car, it accelerates and reaches a speed of 8 meters per second. So another thing I want to do is I want to find the displacement during this time. So here I can use another kinematics equation. Displacement is equal to my initial velocity plus my final velocity over 2 times time. So here I'm going to have 0 plus -8 over 2 times 4 seconds. And this is going to give me a displacement of -16 meters. So that tells me that from time 0 to time 4, I've gone a displacement of -16 meters. So I started at plus 10. So that means that after 4 seconds, I've gone -16 meters to this point. So this is my origin, 0 meters. And we can call this -6 meters. Then at t equals 4 seconds, I am at this point. Okay, and I'm moving at a speed of -8 meters per second at this point. So I started off speed of 0 meters per second, started accelerating in this direction, and got to this point. So now I stop accelerating and I just move at this constant speed of 8 meters per second in this direction. And so the displacement from that time will be simply velocity times time. And so I'm going at negative 8 meters per second. And from this point, I'm going to be traveling another 3 seconds. So that means I'll have gone negative 24 meters. And that is negative 24 in respect to this point. So if I continue drawing this line, I've gone negative 24 meters of negative 6 in this direction. So my final position at t equals 7 seconds will be negative 30 meters. So final position is negative 30 meters. Okay, so now I'm going to do the velocity and acceleration graph. So I'm going to keep these drawings. I'm just going to erase. Oops. Actually, I'm just going to clear this area. Okay, so we know our final position is negative 30 meters. That was right. Sorry. 30 meters at t equals 7 seconds. Okay, so now for the velocity graph and acceleration graph. So I start with an initial velocity of 0 meters per second, and at t equals 4, I ramp up to negative 8 meters per second. Then, from t equals 4 seconds to t equals 7 seconds, I then move at a constant velocity. So now, my acceleration graph is kind of, if you're familiar with calculus, will be the derivative of this graph. So from time equals 0, this is negative 2 meters per second squared, to a time t equals 4, I move with the constant acceleration. And then at t equals 4, I stop accelerating. And so from t equals 4 to t equals 7 seconds, I have an acceleration of 0. So this is what your velocity and acceleration graph should look like. Thanks for watching.